of n depending on that integer n. So boleh gunalah in other words. Okay. So tak semua boleh guna integer. Kalau sini real number tak boleh. Okay. Right. The first step is to prove your statement for the first integer, which in this case 1. Okay. So you look at the, you boleh buat macam ni juga this is your statement P, right? So kalau P of 1 is basically the summations of I is from 1 to 1 and then equal to 1 times 1 plus 1 over 2. So you can do left hand side, which is summations of I from 1 to 1, therefore this is 1, and then you punya right hand side pula adalah 1 plus 1 in bracket. Satu cara lagi lah yang you boleh guna 1 times 1 plus 1 over 2, which is equal to 2 over 2, which is equal to 1. Okay. So since the left hand side equal to the right hand side, therefore the statement is true for n equal to 1, which means your P of 1 is true. Okay. Boleh buat macam ni. Kalau nak follow whatever yang written there pun is. So this is equal. Okay. Hence the conclusion. Okay. Alright. So okay lah. It fits the first integer, then your P of 1 is 2. So the next part is to assume first. Okay. Now we assume that the statement of this particular integer k is true. Okay. Which means the summations of I from 1 up until the k term. Okay. Up until term yang ke k. Okay. K term is equal to k times k plus 1 over 2 is true. Okay. So the summations of the first integer n up until the k term is equal to the k times k plus 1 is true. Kita assume first. Okay. Now how do we prove that? Okay. So the next step under step 3 is to prove your P of k plus 1. Okay. The next integer, the next term, the summations of the k plus 1 term. Okay. So we have summations of I from 1 to up until the k plus 1 term. Kalau sebelum ni up until the k term saja. So the next step is to prove the summations of your integers starting from 1 up until the k plus 1 term. Okay. So what you do here is simply by replacing all the k with your k plus 1, because that is the, you can consider as upper bound lah. Okay. Or the last term, k plus 1. Yang tu you boleh simplify. Okay. Which then become k plus 1 times k plus 2 over 2. Okay. So macam mana kita nak ikan statement nombor 3 ni? Prove the P of k plus 1. Okay. This is the step ya. Okay. Alright. So let's consider the left hand side of your P of k plus 1. So this is the P of k. Okay. This is the statement P of k plus 1. Alright. Which one is the left hand side? This is the left hand side of your P of k plus 1 kan? Yes. Okay, so now this is the right hand side of your P of k plus 1. So now you need to prove that for the summations up until the k plus 1 term, okay, the left hand side is equal to the right hand side. So normally we would start from the left hand side. Sebelah kiri boleh nak start dari sebelah kiri sebelah kanan, tapi dia macam complicated. So I think it would better if you always start your manipulation from the left hand side. Okay. So now let's look at the left hand side here. Okay, consider consider the left hand side of your P of k plus 1. Okay, so we have the summations of I. Okay, I from 1 to k plus 1. So I is the term. Okay, the first term, second term, and so on. Okay, which means you have the summation of 1 plus 2 plus 3 plus 4, so and so, plus k plus the next term, which is your k plus 1. Okay, alright, so now we have our assumption earlier that for the summation up until the k term, okay, it is equal to k times k plus 1 over 2. So this is our assumption kan. Kita kata summation up until the k term is k times k plus 1 over 2 term. Okay, so now this part here, summation from 1 until k ni can be replaced by the summations of k, where k is from 1 to, sebab itulah saya nampak lupalah saya nak betulkan yang bawah kan. Nak try lagi kan. Sudah, this one should be, it should be I. Sepatutnya I sebenarnya. Okay, the I. Okay, yang itu adalah I. Yang ni k is, yang ni adalah I. I is from 1 to k, okay, for your summation I. This is the summation up until the k term plus the k plus 1 term sebenarnya. Okay, so 1 tambah 2 sampai tambah ke k term tu can be simplified to this one. Okay, the summation of I from 1 to k, okay, plus with the next term, okay, plus with the next term, which is k plus 1 term. Okay, and by assumption in the previous
yang tu TH term kan, so dia kan summation daripada 1 sampai k plus 1 kan.
apa dah di depan last. Okay, di depan last tak? Okay, the summation up until the k term by our previous assumption is that it is k times k plus 1 over 2. That is your assumption. Okay, which is yang ni lah. Ini saya return balik pula. And plus the k plus 1, which is k plus 1. Okay, so the k plus 1 term is the k plus 1. So daripada sini lah kita manipulate, okay, so that in the end it can be written as the same as your right hand side of the statement P of k plus 1. So kalau sama, maknanya P of k plus 1 is true because the left hand side equal to the right hand side. Okay, so now next is to make your conclusion. So by the principle of mathematical induction, since P of 1, kita mention P of 1 and your P of k is true, therefore it is true that the summations of I from 1 to n, so n is like the general, not that specific k, equal to n times n plus 1 over 2 is true for all n that is greater than or equal to 1. Students selalu dalam this one is like n1 a1. Makan. Jangan tidak. So itu 4 step. Yes. So the 4th step tu termasuk the conclusion sebenarnya. Itu cara dia. So normally yang jadi complicated tu is on the manipulation process to prove the left hand side of your P of k plus 1 dengan yang sebelah kanan. Itu je. Tapi I think by some exercises tu patut bantu lah. That is induction in general. Okay. So dia satu lagi macam it doesn't make sense lah kalau macam you boleh buktikan nombor 1 betul, nombor 2 betul, nombor 10 betul. Okay, lepas tu kita assume that one specific integer k is true kan. And then tiba-tiba P of k plus 1 pun betul, but suddenly nak kata P of k false pula. So you pernah tengok domino kan, permainan domino ni, dia punya effect tu lebih kurang macam tu tau. Kalau you drop the first block and then dia akan continuously drop the next one until the end block. So you boleh view induction macam tu lah, dia progresses. Any question? Kita cuba satu soalan lagi. Ini kita try buat. Dah? Okay. Okay, this one. Okay, before we start, okay, can you give me the first term of this statement? What is the first term of this statement? Sebutkan yang pertama. Or what is the term in general? The term is I to the power of 3. Okay, the term is I to the power of 3. Which means, normally term kalau dalam sequence ataupun dalam series ni, kita guna A sub I term. Okay, kita belajar kan? Sequence and series. So your first term here is basically equal to I to the power of 3. Okay, which is 1 lah. And the second term will be 2 to the power of 3. Okay. The third term will be 3 to the power of 3. Okay. And then if you have the kth term, then it will be k to the power of 3. Okay. And then say the k plus 1 term. Okay. That will be k plus 1 to the power of 3. Okay. So this is the k plus 1 term. Alright. Just nak ni je. Okay. So saya buat kat sebelah. Space there. So page baru. So this is the summation. Okay. Summations of I to the power of 3, I starting from 1 until n is equal to 1 over 4 plus n plus 2 times with n plus 1 square. Okay, so this is basically your statement P of n. Okay. This is your statement P of n that depends on the integer n. Okay, so obviously the starting n here is equal to 1. Look at the upper bound. Okay, the starting n here is 1. Okay, alright. So now first thing first, what we need to do is to prove, okay, whether your P of 1 is 2. Okay, so how do we do that? So we write down the statement P of 1, okay, which is the statement of the summations of I to the power of 3, I from 1 until 1 lah, kan? Because kita nak tengok the first term, okay, which is equal to 1 over 4 times 1 to the power of 2 times 1 plus 1 to the power of 2. So you have two parts here, the left hand side and the right hand side. Okay. You boleh buat terus ataupun you can do it like this. While on the left hand side we have the summations of I to the power of 3 when I is from 1 basically equal to 1 to the power of 3, which is equal to 1. Okay, how about your right hand side then? Right hand side is simply 1 over 4, 1 to the 2 times 1 plus 1 to the 2, which is equal to 4 over 4, which is equal to 1. Okay, so sama kan? On both sides, left hand side and the right hand side. So therefore, we can conclude that your P of 1 is the root. Let's see, cukup. your P of this specific integer is also assumed. Okay, we just assume this P of that specific integer K is true. Okay, alright. So dia bukan N lah, N is general. So kita nak one specific K. So now what you need to do is write down your statement P of K. Okay, which means the upper bound of your summation tu should be K. So we have summation of, we have I to the power of 3, I from 1 to K. Now kita nak tengok up until the specific summation up until specific integer K. So yang ni kita tukar je lah. And with K. So with K to the 2 times K plus 1. K plus 1 to the 2. So ini assumption saja. Dekat sini pun kalau you place the K the R correctly, another N1 dekat sini. Okay? Okay? Alright, so next part. So now we have the assumption that P of K is true. So what do we do next? Now we prove that P of K plus 1. Okay? Proof. P of K plus 1. Okay? So first thing first, you need to write down this open statement of P of K plus 1. Okay? Kena write it down first. Now we have the summation up until the K plus 1 term. Okay, we have the summation up until the K plus 1 term. So I to the 3, I equal to 1 up until the K plus 1 term. That is on the left hand side. What happened to the right hand side? So simply by replacing your K here with K plus 1. Okay, just replace your K with K plus 1 on your next step. So we have 1 over 4. Then that will be K plus 1 to the power of 2 times K plus 1, K plus 2, K plus 1 plus 1. Okay, so that will be K plus 2 to the power of 2. Okay. So now can we prove that this statement P of K plus 1 is true? So this is when you know you gonna be algebraically terror kot kan. Kadang-kadang kita ingat dulu macam ni tapi boleh juga. So this is the left hand side of your P of K plus 1 and this is the right hand side of your P of K plus 1. So always start lah, senangnya start from the left hand side of your P of K plus 1. From left hand side, we have the summations of I to the 3, I from 1 to K plus 1. Okay. So we agree that the summations of I to the 3, I from 1 to K plus 1 is equal to the summations of I to the 3 where I is from 1 up to the K term plus with the K plus 1 term. Setuju tak? Kalau kita ada tambahan 11 term, okay, sama je kalau kita tambah the first to the 10 terms, tambah dengan term yang 10 yang, sorry, term yang ke-11. Kan? Make sense tak? Okay. So, now, this is what you should do lah. Okay. What is the summations of I to the 3, I from 1 to K? From step 3 tadi. Sorry, step 2. This is our assumption kan? So now kita nak guna the inductive step lah. Kita nak guna this step, okay, to plug in into our P of K plus 1. So it is the summations of I to the 3 where I is from 1 to K is 1 over 4 K cos 2 times dengan K tambah 1 cos 2. Sebab yang ni adalah daripada assumption. This one. is our assumption, right? P of k, which is the summation up until the kth term. And this is the summations up until the kth term, which by assumption, it is equal to yang ni lah. Okay? So what is the k plus 1 term then? Apa dia punya k plus 1 term? Apa yang saya mention tadi? Kalau first term is 1 squared, 1 cube. The second term is 2 cube. The kth term is k cube. So the k plus 1 term is k plus 1 to the power of 2. Okay? So now masukkan you punya the k plus 1 term, which is k plus 1 to the power of 3. Kat sini lah you kena dekat kepakaran algebra ya, untuk make sure that dia sama dengan sebelah kanan p of k plus 1. Saya rasa saya tak ada jawapan dia, tapi why do you try? Okay, so kita nak make sure that it reach the right hand side of your p of k plus 1. Jangan expand kalau you expand jadi complicated. Cuba you cari common factor, boleh tak? Cari common factor. Apa dia? Yang you boleh ambil kat sini. Anyone?
K plus 1.
K plus? Plus 1 apa? K plus 1 squared. Cukup tak? Maksudnya? I would suggest untuk you keluarkan 1/4 sekali.
1/4 ke kosong.
Yang dijadikan dia 4/4 boleh?
Boleh.
Okay. So keluarkan berapa? 1/4 k plus 1 to the power of 2 and k squared plus
K squared
4 times k plus 1. Tak? Setuju? Okay. Alright, lepas tu simplify dalam ni. K plus 1 to the 2. So here you have k squared plus 4k plus 4. Boleh simplify lagi. Which then become 4 k plus 1 to the 2. This is k plus minus 2.
plus plus.
Plus kan?
Ya.
K
K plus 2, K
dengan
plus 2.
K plus 2 term, which is then become k plus 1 cos 2 darab dengan k plus 2 cos 2. Sama tak dengan with the right hand side? Macam this is the algebraic manipulation yang you kena buat lah. Okay. Alright. Jangan expand lah, maksudnya macam case ni kan, student kan nak expand cos 2 cos 3. Kita kena bekerja secara bijak sikit. Okay. Boleh tak complicate you punya.
Ini dapat dari mana?
Alright, done.
Mana?
Now it is equal to,
Tak, 4
means the p of k plus 1 is already proven. Okay, maknanya terulang. Sama. So what can we conclude from here? Since p of 1 and p of k plus 1 is true, therefore your p of n is true for all n that is greater than or equal to. Yang ni kena. You cannot stop here. You must make your conclusion. Okay. Boleh?
Ini kan gantikan dalam bentuk yang ni kan. Maksudnya ni kan dia kata K plus 1 power term. Semasa kalau ikut yang ni kan semua ni
Ada soalan?
of 3. So kalau A K plus 1. So nanti kan K plus 1 of 3. Soalan ni move of 3. Tak macam mana.
Meja tu kosong.
Meja.
Oh,
Kursi je.
nampak? Sebelah 8 kan yang tadi? Sebelah 8.
Naik lah. Cuba dah. Meja tak.
Ya.
Dah terlekeh.
Keras. Macam tengok nak kopi. Apa yang aku bakal kopi tak bertanggungjawab?
Dia pakai induction. Actually, there's another part under induction. Under induction, kita akan discuss dalam bulan. Because it's not the same. Sekejap. You know, this is the symbol for summation, which is hasil tambah. Yeah. So there's another one yang product between n number of terms. Yang ni pun applicable juga kan. Bila nampak kan
Penutupan.
daripada Mr. Azli punya slide tadi tu.
Nampak tu
So dia applicable juga untuk yang hasil tambah. And also, even though dia mostly for equality, you pun boleh guna untuk yang less than ataupun greater than. Okay, let's look at that example. By the way, nampak yang ni dulu lah. By June 2012. Boleh cuba. First thing first, kalau tak ada soalan ni, kalau tak ada soalan ni, macam mana you nak tahu yang ini kita boleh guna induction? How do you know? Kalau tak ada this statement kan? Okay, how do you know that you can use induction method to prove this particular proposition? Dia mesti ada universal quantifier. Okay. Okay. This one is ketiga statement is ada integer. And then ada terms integer. And then you have universal quantifier. Okay, number one. And then you have the object is integer. And then your something happen depending on your end. Okay, so therefore you can use induction method to prove this proposition. Okay, so now therefore the summation of the left hand side of this statement can be written as the summations of your cos sub I from 0 because dia punya starting n is 0 kan, I equal to 0 to n is equal to 4 to the n plus 1 minus 1 over 3. Okay, that is your P of n. Okay, the summations of cos to the I from 0 to n is equal to 4 to the n plus 1 minus 1 over 3. Okay, let's try. Summation. Saya buat terus P of I. So we have the
Kau buat nak
summation
yang?
of for the I is from 1 to n is equal to 4 to the n plus 1 minus 1 over 2. Minus 1 over the sorry, this 0 lah. So the first step is to prove P of 0, yeah? Not P of 1. P of 0. Well, P of 0 means you have the summations of 4 sub I is from 0 to 0 lah. Betul? Equal to 4 to the 0 plus 1 minus 1 over 2. That is your first summation of your first term. What is the left hand side? Good one. Good. And what is your right hand side? Okay, so therefore P of 0 is true. Right? Okay, next. We assume. Now we make the assumption that P of K is true. Kita assume dulu Kita tak tahu ni betul ke tak. Kita assume je. Perfect. So what is P of K statement then? You'll have the summations of your 4 sub I. The 4 sub I is the term. The first term will be 4 to the 0, second 4 to the 1. So I is starting from 0 to K, which means you have 4 to the K plus 1 minus 1 over 3. Betul tak? Okay. That is your assumption. Okay. By the way, maybe you boleh take a note here. Kat sini dulu. What is the first term here? 4 sub 0 ke?
Yes.
The second term will be 4 to the 1, which is 4. The third term will be 4 to the 3. And up until the K term, that will be 4 to the K. And the K plus 1 term will be 4 to the K plus 4 to the Sekejap. 4 to the tak, 01 text. Dia tengok bawah tu lain lah. Okay. Sebab dia alright. So, what do we do next? Yang ni tak perlu tulis sebenarnya. Just apa tu? At least you aware lah. What is the K plus 1 term?
Then A1 equal to for apa ni ikut A K equal to 4 plus K. Jadi equal to K minus 1.
Tak, kita ikut dia punya case term walaupun dia start. Sebab dia macam case term. So, 4 K lah.
Kalau K dia 3 maksudnya
Ada, okey macam ni. Sebutan dia, faham tak? Ini sebutan pertama, sebutan kedua, sebutan ketiga. Bukannya
aku tak berkait faham.
sebutan pertama dia K
Ya,
first term. This is first term.
I
apa benda yang tadi.
What is up here?
Aku tak faham apa yang
Second
tadi.
term, third term, the key
Tapi
term
aku faham
is
lah
this up
apa
here.
yang dia terangkan.
Ini for the key.
Tapi aku tak
Ini
faham apa
first
yang
term, ini second
aku
term.
ayah-ayah masukkan tu apa.
Yang maksudnya kan ni kan first term tapi kan kosong. Kalau kita tu kenapa?
So now
Bukan
prove your
nombor
P
lain
of
sebenarnya.
K.
Kosong tu ni kosong macam kalau
Plus
kita
one
ikut lah.
third.
Tapi kan kita ikut macam nak
Prove
kata di
P
first
of
term
K
benda
plus
ni
one.
kosong.
So
Kosong
first
start.
thing first, what we need to do is to write down your P of K plus 1. What is the statement P of K plus 1? So you should have summation of your term up until the K plus 1 term. Okay? You should have the summations of the 4 sub I, 4 to the I from 0 to K plus 1, which is equal to this case. Yes. 4 to the K plus 1 plus 1. K plus 2 minus 1 over 2. Okay. So now can you prove that the summation up until the K plus 1 term is equal to 4 to the K plus 2 minus 1 over 2. Boleh tak? Okay, let's see. So we start from the left hand side, yeah? Always starts from the left hand side. It's easier for you lah. So on the left hand side, we have the summations of 4 to the I from 0 to K plus 1, okay? Which is basically equal to the summations of 4 sub I, superscript of 4 to the I from 0 to the K plus with your K plus 1 term. Okay, to the K plus 1 term. Okay. So, with our assumption on the second step, okay, the summations of 4 to the I from 0 to K is equal to 4 to the K plus 1 minus 1 over 3. So this is the summation up until the K term. Plus with the K plus 1 term. What is the K plus 1 term here? 4 to the power of K plus 1. Cuba you simplify sampai you dapat right hand side yang P of K plus 1. Let's see. Cuba. Always look for common factor, boleh tak? Nanti jangan try expand pelik-pelik. Ni dah lah salah expand, lepas tu simplify salah pula. Ya.
Power ni kan kita boleh pecahkan ni.
Kalau pecahkan buat boleh.
Yang tu kalau tu.
1/3 kan?
Mana betul.
Apa lagi yang kita boleh problem? 4 to the K plus 1.
Plus 1.
4 to the K plus 1. Dan dia tinggal apa? Satu. Okay. Siapa ingat?
One plus
3
Oh, jadi 1 plus 3.
Tiga je.
Oh, jadi
Tiga je. Ya, keluarkan 1/3 4K plus 1. Ataupun kan
Bilik dia tu macam tu je.
betul lah. Betul.
Tiga je.
Saya kawan dikit ni sebenarnya. 3. Lepas tu dekat sini tolak 1/3 kan. Whereby when you actually have 4 over 9. 4 over
Kita. Ah, hancur.
4 over 3. 4 to the k plus 1 minus 1 over 3 ke? Masuk.
1 plus 3.
Yang boleh tak?
4K plus 1 minus 1 over
4 to the k sebenarnya dia adalah macam ni kan? Dia adalah kalau saya pecahkan boleh tak sebab macam ni? Sama kan? Make sense? Lepas tu this one is like 4 to the k plus 2 because this one is like 4 to the power of, so you have 4 to the power of k times 4 to the power of 2 which can be simplified to 4 to the k plus minus 1 over 3. So ketiga ni boleh buat keluar lah sebenarnya. In the end you dapat 4 to the k plus 2 minus 1. Apa kita punya right hand side?
4K 1 plus 1 minus 1 plus 2.
So boleh lah nak rewrite tu. Kalau tak tahu this is true or not. Sama je. Okay. Ya boleh. Dia macam mana? Itu ada 1/3 of 4k plus 1 plus 3 over 3 of 4 to the k plus 1. So akan jadi 4/3 k 4 to the k plus 1 minus 4. Ini salah satu cara simulation apa tu simplification yang you boleh buat.
Macam ni tak boleh buat.
Doktor ni boleh nak bagi cepat sikit. Okey, boleh tak sama dengan right hand side? Okey, lepas tu make a conclusion. That's it. Since complete your sentence. Then complete.
Nak baca dulu.
Satu lagi boleh?
Boleh.
Sentuh lah. Tak ikat lah.
Tak bluetooth.
Excuse me.
Then
Pen aku ni bukan betul tak perlukan cas.
from December 2014.
December 2020.
Ya ke?
Itu for
Kamu bila ke? iPad eh?
Hah?
iPad. Xiaomi.
Korang orang kaya memang
Wow.
aku orang kaya.
Samsung.
Industry for all.
Soalan mana?
December 2014.
Okey, tengok dekat December 2014 nak cakap satu lagi soalan lain. This one related to equality.
Tapi fashion. Because lagi senang nak ambil dia sebab sekarang bawah tu kan dah sama, so boleh terus sekali cancel.
Kan Najwa kata betul.